Multivariate methods. In Chapter 4, we discussed the parametric approach to classification and regression. Now we generalize this to the multivariate case, where we have multiple inputs and where the output, which is class code or continuous output, is a function of these multiple inputs. These inputs may be discrete or numeric. We will see how much functions can be learned from a labeled multivariate sample and also how the complexity of the learner can be fine-tuned to the data at hand. Multivariate data. In many applications, several measurements are made on each individual or event generating an observation vector. The sample may be viewed as a data matrix. X equals to x1, x12, and so on to x1d, x21, x22, and so on to x2d, x1n, x2n, and so on to xnd, where the d columns correspond to d variables, denoting the result of measurements made on an individual or event. These are also called the inputs, features, or attributes. The n rows correspond to independent and identically distributed observations, examples, or instances on n individuals or events. For example, in deciding on a loan application, an observation vector is the information associated with a customer and is composed of age, marital status, yearly income, and so forth, and we have n such past customers. These measurements may be of different scales, for example, age in years and the yearly income in monetary units. Some, like age, may be numerical, and some, like marital status, may be discrete. Typically, these variables are correlated. If they are not, there is no need for a multivariate analysis. Our aim may be simplification, that is, summarizing this large body of data by means of relatively few parameters. Or our aim may be exploratory, and we may be interested in generating hypotheses about data. In some applications, we're interested in predicting the value of one variable from the values of other variables. If the predicted variable is discrete, this is a multivariate classification, and if it is numerical, this is a multivariate regression problem.